Hello, and the purpose of the day is I can apply translations and dilations to a quadratic function, part 2, and I can use graphing calculators. So a transformation summary on quadratics is, if you recall, we have a vertical shift when I have f of x plus c, and that means I am going to translate the quadratic 3 units up. If I have f of x minus c, I translate that quadratic 3 or c units down. A reflection, I have an x-axis reflection if I have a negative in front of my number that's in front of x squared, and I have a y-axis reflection if I have f of negative x. For a stretch and compress right here, I have, it's all about whatever a is in front of my function. So if the absolute value of a is greater than 1, I have a stretch. If the absolute value of a is between 0 and 1, I have a compress. And again, a stretch, if you think about that, means our parabola is getting thinner, and a compress, means that that parabola is getting wider. So just some other words to think about what stretch and compress mean. What is new, and we will talk about more about today, is a horizontal shift. So you will see that if you have a function in the form of, f could be any number right there, and then in parentheses, x plus c, the quantity squared, that's actually going to translate c units to the left. So it's a horizontal shift. If I have a number, so for f, and the quantity x minus c squared, that's actually going to go to the right c unit. So it goes the opposite way we would think, horizontally, which is left and right, and we'll see that a lot today with our graphing calculators. So please make sure you jot down these notes so you have the transformation summary of what we talked about yesterday and what we will talk a little bit more about today. So now I'm going to go through a little bit of an introduction on the graphing calculators. Now, this is what we are going to go through in class, but I want to give you some prior knowledge so that a little bit of this won't be entirely new and we can start to use those a little bit more in class and a little bit quicker. So basic graphing functions for the TI-83 and TI-84, which is the calculators that we will be using, is that this has a lot of benefits to the abilities to graph functions and to identify properties those functions possess. The purpose of this guide is to help you through some of the basic operations that can be done involving graphs. Finding the y-intercept, zeros or x-intercepts, and minimum and maximum points on a graph. Within this guide, you will notice some words that are bold and put within quotes like this. These words denote keys on your calculator or words that appear on its screen. The first step in any graphing problem is to draw the graph. On the TI-84, 83, and TI-84, this is done by going to the function screen by pressing the y equals button and entering the function into one of the lines. After the function has been entered, press the graph button and the calculator will draw the graph for you. So you can see below there are two examples, y equals x squared minus 4 and y equals negative x squared plus 4. So they have a few different features, and you can see that's what your graphing calculator will look like when you also use that in class. Page 2, finding the y-intercept of a graph. The y-intercept of a graph is the point where the graph crosses the y-axis. Because of the way graphs like these are set up, any and all points that lie on the y-axis have x values of 0. Because of that, we can use the value function on the calculator to find the y-intercept of any graph. After entering the graph into the calculator, press second, then trace to go to the calculate window and highlight value. Then press enter. This will take you to the graph with x equals displayed at the bottom of the screen. Type in 0 and then press enter. The graph will now display a cursor where the y-intercept is located along with the x and y coordinates of that point and the function equation of the graph selected. So in this example, you can see in that graph x equals 0 and y equals negative 4, so the y-intercept is negative 4. And that makes sense because the y-intercept is when x equals 0 and again where y crosses the y-axis. Page 3, finding the zeros of a graph. The zeros of a graph are the points where the graph crosses the x-axis where y is always equal to 0. The idea of a zero is similar to that of the y-intercept, but the method used to identify the 0 points is different because we cannot simply enter y equals 0 into the calculator and have it return the corresponding x value. After entering the graph into the calculator, we will press second and then trace to go to the calculate window, which we have already spoken about, and highlight 0, meaning we want to find a 0. Then press enter. This will take you to the graph, but instead of prompting a number, the calculator asks you to identify the left bound. This is simply some point on the graph that is to the left of the point that you want to identify. Use the left or right arrow keys to move the cursor along the graph until it is to the left of the point you want to identify. Then press enter. So you can see in the graph below that this is the point we want to identify right there. So we are going to go somewhere to the left of it. So this black dinking cursor light right there is going to be to the left of that orange point we want to find. You will now see a little arrow above the point you marked pointing to the right, and that the calculator is now asking for the right bound. The arrow is an indicator that will be used to tell if you entered valid points. The right bound is a point to the right of the point you wish to identify. Use the right arrow to move the cursor along the graph until it is to the right of the point you want to identify. Then press enter. So as we look at the graph below, this is now the blinking cursor right there, and that's now to the right of this point right there that we want to find. Now there should be 2 arrows on screen. If you entered the points correctly, the arrows should be pointing towards each other. If they are not, you will receive an error message after this next step, and you will need to redo the 0 function. If there are multiple zeros in your graph, repeat the process for each one until all zeros are identified. So in this case, we have 2 zeros, one right here and one right here. The calculator should now be asking you to guess. Use the left arrow key to move the cursor along the graph until it is as close as possible to the point you want to identify. Then press enter. After this, the calculator should show the coordinates of the 0 you have located along with the cursor over the location of the 0 on the graph selected. We will get lots of practice with this during class with the graphing calculators. Page 4, finding the minimum maximum of a graph. The minimum of a graph is the point with the lowest y value for that graph. The maximum is the point with the highest y value. The process for identifying these points is very much like that used to identify the zeros, but remember that the minimum and maximum functions will not find the same thing as the 0 function for most graphs. Because of this similarity, this guide will only cover the minimum function in detail. After entering the graph into the calculator, press second, then trace to go to the calculate window, which we know very much about, and highlight minimum. Then press enter. We are now going to find the minimum of this equation, or this function. Use the left or right arrows to move the cursor along the graph to the left of the minimum and identify left bound by pressing enter. You will see a little arrow above the point you marked pointing to the right. Use the right arrow key to move the cursor along the graph to the right of the minimum and identify the right bound by pressing enter. Now there should be 2 arrows on screen. If you entered the points correctly, the arrows should be pointing towards each other. If they are not, you will receive an error message after this next step and you will need to redo the minimum function. Use the left arrow key to move the cursor along the graph until it is as close as possible to the point that you want to guess, and then press enter. After this, the calculator should show the coordinates of the minimum along with the cursor over the location of the minimum of the graph on the graph selected. Finding the maximum works in a similar manner to finding the minimum, with the only significant differences being the menu selection and the end result. Some graphs may contain either a minimum or a maximum or local regions which possess relative maximums or relative minimums without being the true maximum or true minimum for that graph. In those cases, you may need to use a combination of these two functions or use one or both functions more than once to identify all such points. Thanks for listening. Have a great day. Bye-bye.